The derivative of a function can tell us a lot about its graph. We have here the graph of a polynomial function, and if you'd like to know, it is f of x equals 3x to the fourth minus 4x cubed minus 12x squared plus 5. I want to chop up this function into a few intervals. One of them goes from negative infinity to 1. Then we'll look at from 1 to 0, from 0 to 2, and from 2 to infinity. Notice that on the interval from negative infinity to negative 1, I didn't make clear, but I think I have now, that the intervals we're talking about are intervals on the x-axis, and then we're looking at the function above or below those intervals. Okay, the interval from negative infinity to 1 is an interval over which f is decreasing. Likewise, f is decreasing on the interval from 0 to 2. F is increasing over the interval from negative 1 to 0, and then again on the interval from 2 to infinity. If we visualize a tangent line for the function on the interval from negative infinity to 1, we'll see that the tangent line has a slope that's negative. Therefore, we can say that f prime is negative. That's true on both intervals where the function is decreasing, and on the intervals where f is increasing, the derivative is positive. Furthermore, we have 3 places where the tangent line is horizontal, or another way to put it is that we have critical numbers at x equals negative 1, 0, and 2. Negative 1 here, 0 here, and 2 here. Looking at just like, say, a number line with negative 1, 0, and 2 on it. If we look at the graph, to the left and right of negative 1, we see that to the left of negative 1, we have negative derivatives, and to the right of negative 1, we have positive derivatives. So over here on this number line, I'm just going to put like a slash going down to the right that exists to the left of negative 1, and a slash that's going up to the right that exists to the right of negative 1. And folks, that's what's going to happen every time you have a local minimum. There's a local minimum at x equals negative 1. Just to emphasize here, the minimum value is 0 because this is where our graph is touching the x-axis. If we now turn our attention to the left and right of where x equals 0, we see that to the left, the function is increasing, or we have positive derivatives, and to the right we have negative derivatives. So on our number line here, we have increasing to the left of 0, decreasing to the right of 0, so we know we have a local maximum at x equals 0. And again, by the way, the maximum value, I wrote 1 there, is 5, right? Finally, turning our attention to where x equals 2, we have derivatives that are negative to the left of 2, positive to the right of 2. Over here on the number line, we see slashes, one going down, one going up, and that means we have a local minimum at x equals 2, and the minimum value is negative 27. Of course, the derivative isn't telling us the values of the min or max. Anytime we need an actual point on the graph, we're getting that from the function itself. But here's the point. If I've got a critical number and the derivative changes signs from either negative to positive or from positive to negative, then I have a local max or a local min. All of this is summarized by the following. We have something called an increasing-decreasing test, and it says what we just said. If f prime is positive on an interval, then f is increasing for positive on that interval. If f prime is negative on an interval, then f is decreasing on that interval. I think it makes sense. Then we have something called a first derivative test. If we've got a critical number, c, of a function f, and the derivative changes from positive to negative at c, then f has a local maximum at c. If the derivative changes from negative to positive at c, then we have a local minimum. But if the derivative is positive both to the left and right, or negative both to the left and right, then there's no local minimum or local maximum. And you can visualize this by thinking about y equals x cubed, right? At the origin here, we have f prime is equal to 0, but the derivative is positive to the left of 0, positive to the right of 0. There's no local minimum or local maximum.